Welcome to Mr. Hill Australia. We have the patterns in algebra, the first indicator for stage 3, year 5 and year 6, which is what stage 3 is, and very similar. You need to be able to describe or describe the rule. Can you continue and create patterns with fractions, decimals and whole numbers? Now year 5 only has addition and subtraction, whereas year 6 it could be multiplication and division, but we're only going to look at addition and subtraction because we're going to look at some really hardcore ways to look at the rule and get our rule. This is a bit of a step up into high school styles, but I figure what's the point of messing around with the basics when we can just really get into it. And it looks a bit complicated, but I promise you it's actually really easy. So can you describe this first pattern, which goes 4, 7, 10? What's happening each time there? Is it increasing or decreasing? Yes, increasing by 3 each time. So that means what comes next? 4, 7, 10, 13, 16, and so on and so forth. So we've got a table of values. Now we're calling the pattern the x-axis or the x stuff. Okay, so when x is 1, that means it's the first in the sequence. When x is 2, it's the second number. When x is 3, it's the third number. So we're just going to move this data, move these numbers into the table of values. So what's our first number in the pattern? Yep, 4, next number, 7, third number in the pattern, 10, fourth number in the pattern, 13, fifth number in the pattern, 16, and if you want to get to the 10th term or the 10th number in the pattern, we could continue to count, but that's going to run us into an issue when you get asked to do, well, what's the 100th in the cycle? What's the 50th? What's the 247th in the sequence? And if we have a rule, a formula that we can create, then we are going to be legends at this. So we're going to leave that at the moment. Now, our rule creator means whatever, so y is like as the pattern goes. So you're looking at whatever comes into this box is the amount the pattern moves each time. So how much did the pattern move each time? Well, it went up by 3. So because it went up by 3, we're going to leave it at a positive 3. Bang. So whatever this number is going to be 3 times whatever's in the x at the time. Okay. And the last bit is whatever y was when x was 0. Now we haven't looked at that yet, have we? Now think about it for a sec. How are we going to figure out what number would go here? So as we're going this way, it goes up by 3. 4, 7, 10, 13, 16. Well, let's go backwards and see what happens. 16, 13, 10, 7, 4. Can you see what's happening? If we go to the left, it's doing the opposite. So if you're going to the left, it's going down by 3. Okay, and that's how we figure out what will go there. So 1 is going to sit there. So this number here is just going to be whatever it says at y when x is 0. So in this table, in our pattern, it is 1. So we're just going to change that to 1. So whatever goes in that section is this box. Whatever goes in this section is how much it goes up or down as you go across. So now we literally have discovered and created a formula for what has to go where y is if we know what x is. Now we always know what x is because that is the thing that we know, and we have to find out what y is. So if x is 10, we're going to put it into our formula. So the thing we want to know is 3 times 10 plus 1, which means it is 3 times 10, which is 30, plus 1. Now, let's just do it for fun. What if we had to find out the 12th in the sequence, the 12th number? I mean, you could just go plus 3 again, or you could use our formula. So y, which is what we want, is 3 times whatever x would be, which we just said was 12, plus 1. So 3 times 12, give you a second to figure that one out, 36 plus 1 is 37. And as you can see, that would be plus 3 plus 3. So, foolproof, isn't it? So, I encourage you to have a crack at this next one on your own and see what happens. So first of all, continue the pattern and then put your numbers in here. Okay, how'd you go? I hope you went well. So this time we went down, didn't we? Down by 3, down by 3. So what would come next if we're going down by 3? 6. What comes next if we're going down by 3? 3. So, what's our first, oh, that's not meant to be there yet. What's our first number in the sequence? 15. What's our second number? 12. Let's make that orange and bold. What's our third number? 9. What's our fourth number? 6. What's our fifth number? 3. What's our 10th number? Well, we're going to work that out in a second. So let's bounce back. 3, 6, 9, 12, 15. What goes here? 18. And look at that. The sequence is still in a beautiful order. Okay. So y is always going to be our thing we're going to work out, which is why it's on that side of the equals. So what is the change each time? What's happening each time? Yes, it's going down by 3. So if it's going down, we have to use a minus. So minus 3, a negative 3, times whatever is in the x. So we'll explain that in a second. And in other words for this, what y is when x is 0. X is 0 at 18. So here we might have a very, very, very quick lesson on negative numbers here. So a negative number, when you times it by something, it's whatever that number is times this number normally, and then it's just a negative at the end. So minus 3 times 1 is minus 3, minus 3 times 2 is minus 6, minus 3 times 3 is minus 9, and so on. If x is 3, we did minus 3 times 3, which is negative 9, plus 18 will get us back to 9. Okay. If we had minus 3 times 4, that's going to give us a minus 12 or a negative 12. So if you started at negative 12 and you had to add 18, you would go from negative 12 back to 0. We've used up 12, and now we need 6 more. Okay, and that's the 18. So you went 12 to get to 0 and 6 more to get to 6. And that's what this plus 18 is. So this is a tricky one. I wonder if you can tell me what negative 3 times 10 is. So it's just whatever it would be normally, but with a negative at the front. So 3 times 10 is 30, and then a negative for that, so negative 30. So think of it like this. If you had negative 30, so you could picture it like this. You're 30 meters underground. You're 30 meters underground, and then you raise yourself up 18 meters. So you're still underground, right? So that means you are still 12 meters underground. So therefore you are at a negative 12. Oh no. negative 12. You could also think of it as like if you owed someone $30 and then you paid them $18, you still owe them some money, right? You still owe them $12. So you're still at a negative 12 of your net worth. Okay. So in this last one, we're working with the decimals. And I think you'll be able to figure this one out. So start at 0.4, 0.8, 1.2. It's looking very similar to 4 times tables, isn't it? Yes, 1.6, 2.0, and so on. Do we need the 0.0? No, but it's consistent with, you know, the 1 decimal place. Anyway, so our first number, 0.4, goodness me. We might need to make this bigger. Next number, 0.8. Next number, 1.2. The fourth in the sequence, 1.6. 6. The fifth in the sequence, 2.0. The 10th in the sequence, interesting. You might have already figured that one out. Now let's just go backwards. So it's going down by 0.4, down by 0.4, down by 0.4, down by 0.4. 0.4 minus 0.4. Well, look at that. It's a big fat 0. Well, that's easy for us. That means we've already got that sorted out. And because it's plus 0, we don't have to do anything else for that. So if it's plus 0, is it needed? If I had $50 and someone gave me $0, would I care? Would it make a difference to me at all? No. So we don't even need to say it. So y equals how much it changes each time. Now it's going up by 0.4, isn't it? So it's 0.4 times x. Now let's test it out. What's 2 times 0.4? 0.8. So if x was 2, it'd be 0.4 times 2. Y, so 0.8. Let's test our formula. 0.8 equals 0.4 times 2. Yes, it does. All right, let's have a look at the fifth one. So we're double checking. 2.0 equals 0.4 times 5. So it kind of looks like 4 times 5, and that kind of looks like 20. So yes, 2.0 is 0.4 times 5. Now we want to look at what it's going to equal at our 10th number. So if x was 10, which is it is here, so 0.4 times 10. Well, I think you know how to times anything by 10. We're going to jump our decimal 1. And it takes us to 4. And to keep it consistent, we can just go 4.0 just for fun. So, moral of the story. We're going to write our formula as y equals something times x plus something. Okay? And you can use that, you can use whatever letter you want. It doesn't matter. Okay? We normally do y equals mx plus b, but we don't really have to go that deep into this. So you're always looking for y. So y is always going to be the letter. So then you look at your pattern. How much does it move each time? So does it go up by 3? If it does, we just put a 3 there. If it goes down by something, we do a minus whatever it's going down by. And then it's plus whatever it is when x would be 0. So whatever is going to go in here. So when you're writing in your book or something, it's always a good idea to have a table of values there ready with a 0 there. So the pattern starts at 1. Make sure you remember that. The pattern starts at 1, but you want to know what happens at 0, which is just going to be 1 jump backwards. Okay. I guess the last thing is, well, what happens if this is a negative number? Well, if this ends up being a negative number, instead of doing plus at the end, you do a minus. So if this number was minus 5, for example, then you would just do blah, 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 minus 5 instead of plussing. Because a plus and a minus together is actually a minus, which you will learn later. So once you've got your rule, it's good to double check that it fits. And hopefully this helps. And if it doesn't, I want you to write to me. Also, let me know if there's any other topics that you're struggling with, so maybe I can do a video for you for that. Anyway, thank you so much for listening, everyone, and have a fantastic day.